If we observe PV power plant closely, we will find a box under some PV modules. This is the combiner box. So what is combiner box? Series connected PV modules are called PV string. The primary function of combiner box is to combine parallel connected PV strings with each others so that higher PV output current is obtained. Individual PV strings are connected using bus bars and both electrically as well as mechanically protected inside an enclosure. Combiner box comprises of several components. To understand them, let us discuss each of the components. The first component is PV string protection device. PV string protection devices is used to protect individual PV string against PV overcurrent. A fuse is typically used for this purpose. The second component is DC bus bar. DC bus bar is the connection point for several PV strings. It brings multiple strings into a common conductor. It is made of solid copper conductor and thin plated for corrosion protection. Next is disconnector switch. This device allows the combiner box to be safely disconnected from solar charge controller or grid inverter before maintenance work is carried out. Hence, it will minimize the occurrence of accident. The next component is surge protection device. This device is used to limit voltage in the event of overvoltage due to lightning strike. Surge protection device is wired to positive DC bus, negative DC bus, and ground. The fifth component is enclosure that houses the internal components and protects them for harsh environmental conditions. The last component is grounding bar. Grounding bar provides grounding connection of the box, if made of metal, and to divert voltage from surge protection device when overvoltage occurs. When designing a combiner box, you should consider the following. The enclosure is located outdoor, thus it must endure a wide range of environment conditions, resist against UV, and have a high IP rating to avoid water and small object intrusion. IP rating stands for Ingress Protection Rating that is used to define level of sealing effectiveness of electrical enclosure against intrusion from moisture and foreign objects, such as tools and dirt. Combiner box is designed in accordance with IEC 603647712, that is, requirements for special installation or locations. Solar photovoltaic power supply systems. Ambient condition and power losses of the components affect the heat in combiner box. Managing the heat in the combiner box can prevent overheating and derating of the internal components. Maintaining definite separation of the positive and negative sides prevents accidental short circuit. All cable connection must be securely tightened to prevent fire hazards. Now, we are going to discuss best practices of combiner box that are the good and bad example. Let's start from the enclosure materials. There are two types of material that make good enclosure: polycarbonate and metal. The most recommended material is polycarbonate due to its durability in a wide range of environment, resistance against UV, and characteristic as insulating material. Combiner box must be safe to touch in case of fault or live conductor makes contact with the box. This could be achieved by having double insulation or grounded box if conductive material is used. Do not forget to put additional wire between the box and door to obtain safe grounding. Next is the combiner box dimension. The dimension should not be too small. Why? First, spacious area inside combiner box provide better cooling for the internal components. Second, sufficient space is needed to work on the box during installation and maintenance. Very small combiner box is prone to unexpected mistakes. The combiner box must be installed in a safe location and below the PV modules to maintain the desired internal temperature of the box. combiner box must be fixed and mounted firmly using suitable fasteners. Do not use cable ties. Another important note for combiner box installation is to put warning sign electrical hazard. This is especially important as during the day, high voltage DC may exist on the busbar or non-isolated live conductors inside the combiner box. Preventive measures before opening the box, such as alerting technicians with warning sign of electrical hazard, is strictly recommended. A good combiner box is also equipped with lock to prevent access from unauthorized person. Next, we will discuss the enclosure protection. A good enclosure should have been rated with IP45 class or the recommended IP65 class that protects against dust and powerful water jet. To achieve this, the door should have rubber seal and cable glands at the cable insertions to avoid water entering the box. Absence of rubber seal around the door and cable glands will allow water and animal to enter the box. This is what happens when combiner box is poorly protected. There is insect nest inside the box that indicates there is enough space for animals to enter the combiner box. In the absence of proper cable gland, cables will be exposed to sharp edge of the enclosure that can damage the cable isolation. How to improve the quality of bad combiner box? First, install rubber seal around the door and close the big hole at the bottom of the box. Second, reorganize the cable installation. If possible, recalculate the required cable size because overrated cable will reduce its flexibility. And third, drill holes for the cable glands and use glands corresponding to the cross-section of the cable. Now, how can we indicate the ingress protection of an enclosure is good or bad? Bad IP rating is indicated by water intrusion, sign of corrosion, and animal inside the box. Regular check and cleaning should be done as preventive maintenance. Close the door of the combiner box properly. All cable insertions should pass through cable gland. The gland must be correctly sized and tightened corresponding to the outer diameter of the cable. Do not put several cables through a single gland. Seal the air vent on the enclosure to increase the IP rating. However, drain valve or breather should be provided to minimize condensation. Enclosure that rated with IP equal or greater than IP65 should provide drain valve or breather to minimize condensation. It is recommended to have a pre-assembled combiner box that is factory tested in accordance with IEC 61439. Check during commissioning that the combiner box is rated at IP66. If written information is not provided, ensure that there is no open hole bigger than 1 mm. We must obviously avoid corrosion in combiner box. How? Provide barrier between corrosive material and metal housing by painting anti-corrosive paint. Consider using stainless steel material if metal box is required. Hot dip galvanize the metal box or provide additional zinc or aluminum coating. Use anti-corrosive materials such as polycarbonate or polyester. Next, let us discuss about heat management of combiner box. Surrounding environment determines ambient temperature of combiner box, thus devalue the internal electrical components. The combiner box must be installed in a safe location and below the PV modules to maintain the desired internal temperature of the box. To improve a bad installation that affects heat management, do the following. Relocate and install the combiner boxes under the PV modules. Ensure that there is no direct sun exposure at any time of the day. Rotate the box in accordance with predefined position that is written in the specification. If relocation is impractical, provide a robust or fixed roof on top of the box. Inside the combiner box, obviously there are electrical components. The electrical components inside the combiner box are string protection devices, bus bars, surge protection device, switch disconnector, and grounding bar. These components must be selected and installed properly to achieve a proper operation and protection of the PV arrays. What to consider when installing the electrical components? All components should be DC rated and are able to accommodate voltage up to the maximum voltage of the PV strings. Ensure that the current carrying conductors are correctly sized and secured by protection devices from being overheated caused by excessive current. Protection devices should also be properly sized to avoid unresponsive devices or unexpected trip. Using protection device that can be reset, such as MCB, is recommended due to the limited spare parts in rural areas. Similar to electrical hazard warning that is attached outside the enclosure. The inside part of enclosure should also attach electrical wiring diagram to easily identify component. Each PV string must be protected with a string protection device if a combiner box has more than 2 strings connected in parallel. The protection device will protect the connected cables and PV modules against overcurrent and reverse current in PV strings. This device will disconnect the faulty string and keep the rest of the strings in operation. Why and when is string protection device needed? The reverse current in PV strings occurs in the event of faulty wiring or short circuit in a PV module. During normal condition, the current of each string is summed and fed into the charge controller. Once electrical fault occurs, the voltage of the faulty string is significantly lower than the healthy ones. This results in flow of current from the healthy strings to the faulty one instead of the solar charge controller. A considerable sum of current from the healthy strings may increase the temperature of the faulty PV module as well as the conductor. It also possibly causes fire if no overcurrent protection is installed. What are things to consider when selecting string protection device? First, only consider protection devices that have proven DC switching capability. Second, it is recommended to use MCBs than fuses. MCB is more sensitive, easy to identify faults, able to be reset, safer, and also provides individual string isolation. Third, if fuse is preferred, use PV type of fuse specifically designed for photovoltaic installation. And fourth, the current capability of the protection device should consider the rating factor in case of high ambient temperature. It is safe to consider the rating factor at ambient temperature of 45 degrees Celsius. If string protection device have been installed as shown in the picture, how to fix such installation? Main fuse is not necessary to be installed as there will be a small chance the fuse will burn. It is recommended to remove the main fuse and bypass the cable since the fuse will generate heat when current is flowing. Replace all AC-rated MCBs with DC-rated protection devices. AC MCB must not be used because the circuit in the combiner box is DC circuit. AC-rated MCB may not be able to extinguish the DC arc in case of fault current or short circuit current. The function of a switch is to interrupt the circuit from or to power source, in this case PV array and the load. During the event of disconnecting, the internal contact detaches and an electric arc will be created as the current jumps across the air gap. In this period of time, the arc must be extinguished to stop the flow of current through the circuit. As the characteristic of AC and DC voltage is different, the AC and DC switches extinguish the arc differently. In the AC circuit, the voltage alternates in sinusoidal from 50 times per second between positive volt and negative volt. Since there is a point at which the voltage is at 0 volt, the switch will interrupt the connection as well as extinguish the arc particularly at 0 volt. Unlike the AC circuit, DC circuit is constant and doesn't alternate. Since there is no 0 volt, the AC switch will not interrupt a DC circuit. A DC switch uses magnet to attract the arc from the air gap and extinguish it. Therefore, never use an AC switch that is not equipped with magnet, as is unable to extinguish the arc. Option to use a string fuse instead of blocking diodes. Blocking diodes cause additional drop of voltage for about 0.5 to 1 volt that leads to significant power losses. The function is better served by a string fuse. Why protection devices should be installed on positive and negative sides. To protect the string cable in case of double ground fault. Double ground fault occurs when the negative and positive sides touch the ground at the same time. In this case, fault current path may still be existed if protection device is not provided. To provide isolation at both positive and negative sides. Consider ambient temperature, power losses, and ideal temperature of the internal components when designing the layout of the installation. Interrupting a relatively high voltage DC circuit may cause electric arc and possibly lead to fire hazards. A switch is required to be installed at the output of the combiner box in order to safely disconnect or isolate the PV generator and load. The switch will ensure the absence of flowing current and voltage during service and maintenance on the combiner box, wiring to the power house, and solar charge controller or grid inverter. Never use an AC rated circuit breaker in a DC circuit. Only use circuit breaker labeled as DC rated for DC application. Pay attention to the DC and AC sign to distinguish DC rated and AC rated switch. Use the correct rating of the switch. The rated current of the switch should be 1.25 times higher than the total current of the connected PV string. For example, if 5 PV strings with short circuit current of 8 amperes are connected in the combiner box, a switch disconnector rated at equal or greater than 50 amperes should be used. It comes from 8 amperes times 5 strings times 1.25. The switch should be DC rated and graded at maximum open circuit voltage of the PV array. In case the voltage reach 1000 volt DC, 4 poles in series are required to break the circuit. Another important component of the combiner box is busbar. What are things to consider when installing busbar? Keep sufficient distance between positive and negative busbars. It is recommended to install connections from different polarities on different sides. Ensure that there is no contact between cable conductors and busbars to avoid damage on the cable insulation, which is prone to short circuit. If rearrangement is not possible, install a non-conductive separator between the positive and negative busbars. Heat shrink insulation tube should be installed on the surface of the busbar to reduce the risk of having short circuit as well as reducing the clearance in between. Using COM busbar on switch is a good example to isolate neighboring cables from each other and from busbar. Uninsulated and bare live conductor or uninsulated busbar is a bad example as it's prone to have short circuit. Lastly, we are going to discuss about cable installation. As the current carrying conductor, cables must be properly terminated and fastened. Bad crimping and connection can lead to increase of heating, losses in wiring, and possible risk of fire. First picture shows poor cable crimping that may risk the safety of the operator and lead to ground fault. Second picture shows burn sign at the terminal of MCB, possibly due to electric arc caused by loose cable connection. First picture shows corrosive terminals. Ensure that the enclosure has high AP rating and replace the corrosive terminals. Second picture shows corrosion that may increase the resistance of the terminals. Cables must be neatly installed and not too long. Cables that is too long causes unnecessary voltage drop. Ensure the voltage drop measured from PV module string to power house not more than 1%. The pictures show good examples of cable installation. Cables are well equipped with cable shoes and screws are properly fastened. MCBs and cables are labeled and correctly colored. This helps the technicians when tracing problems. You also should pay attention in picking the cable color. Use a common cable color to avoid confusion as follows: red for positive DC, black for DC negative, and green or yellow for grounding. These are how to avoid poor cable installation. All cables should be terminated using the correct type and size of cable shoes. Always check the tightness of the crimping by slightly pull the cable. Inspection should be conducted on a regular basis. Use infrared camera to identify loose connections. Poor connection can be indicated by warmer points. Ensure that all the screws and bolts are fastened. If necessary, retorque all electrical connections in the combiner box. It is recommended to use pre-assembled and tested components to avoid unnecessary mistakes when performing assembly on site. Quality assurance, for example continuity test, may also be conducted in the factory to ensure a proper connection and ideal ambient temperature. Avoid using excessive cable terminals. Additional screw terminal will add new source of problems as well as additional resistance. Now let us evaluate this session by doing quiz.